Hello everyone, I'm Xiao Gang. Okay, actually, our engine actually has something like this. Let me show you first. There is something like this. Let me find it. It shouldn't be here. Okay, I found it. Let me show you. Let me expand it first because we don't know. I'll tell you. You need to know there is this thing. The engine has something called WaveModelInfo. Hey, isn't your first reaction to think, can this WaveModelInfo be used to process WA files, right? So, it's pretty good that you can think of this. Then here, it uses WaveModelInfo to process methods like sound_all. Right here, you just need to know this class first. And then here, it also has something called AudioSampleBuffer and SampleBuffer and FSoundWavePCMWriter. You can see this method. Through this method, what can we do? Look at its position. It belongs to the sound category. It can be used to we can write a WAV file as a SoundCue. Unfortunately, I have to tell you, this method is also unavailable in versions after 5.4.3. This is the engine's own module. There is a method inside it called SynchronizeWriteSoundCue. Because I have searched through a lot of code, you will find how it actually works. It actually also iterates over an object, such as SoundCue object. You can see, however, but this thing is no longer usable either. Obviously, the engine has changed a lot. As a result, some other modules are also unusable, so there is no way around this part. But this code works fine in versions 5.3, 5.2, 5.1, and even in 4.27. They can also be used in 4.27. I mean, if you want to study this, it's quite troublesome. Moreover, this involves a change in the engine and also involves the editor because it involves this kind of resource method. So we don't need to put effort into this part. Okay, just to let you know there is such a thing. There is also a procedural audio from SoundWave, just so everyone knows, because that needs to be explained separately. Okay, I'll hide this shadow line. Then in this lesson, I'll guide you through writing this combined SoundWave method. Now, the function signature of this method, what is it? As for its function signature, let's put it here, because these methods are actually quite interesting. You can take a look when you have time. We've hard-coded it for now, but you can actually add more parameters. Here, it passes in a piece of PCM data. The PCM data format has been hard-coded. You can, of course, pass in other PCM data. Other sampling rates are also fine. Then output this data in WA format. So this thing, we need to write it like this. First, we need to describe our data. First, we need to clear our data. Clear this data. Then we need to prepare several structs here. As for this struct, I'll write it in this position. Write it in this position. This position. This thing, I actually just pasted it over. What is this? This is the header. First it has a head, then this head. The structure of each part is like this. Yeah, then, that is to say, in this place, this cheek size. This size includes these two items. It starts counting from this item. So this header information describes this format plus this, the size of the data in this preceding section. Then let's look at this form. This form is mainly 24 bytes. To describe the size of this format, you can see that is this place will describe its format, size, channels, and sample rate. This also includes bytes and some placeholder items. Then here, next is the actual data. This data, it uses a wired data to describe this data, and then finally append its actual binary data. Let's first look at the red underline here. Let's see if it can compile successfully. The reason for the red underline, it might be because I have too many OS here. It's already a bit overwhelmed. Then later we will take this data, fill in our PCM data, and then we can serialize it into WAV format. Actually, this way of thinking is actually the same when we work with images. It's the same because for images, but for images, we have a dedicated, I mentioned earlier about the PNG image format, right? Images have a dedicated read module. Okay, alright. There shouldn't be any issues here. Everyone, please double check. These data structures, they describe what data is. If you are interested what these fields mean, you can search online regarding W waves, how each field is defined, and what it means. We will just start copying directly, okay? We find our convert APM section. First of all, we need to declare these three structures. Let's change the name. This is across different projects. Okay, good. We declare these three structures. Actually, there is also a portion of binary data here, but the binary data is inside this. We don't need to worry about it. Let's first define the structure properly. First, we assign this ChunkID to it. We assign this ID a header. Then, we assign its format this value. We just copy it directly from memory. Assign a WAV. Next, we calculate its size. This is 36 plus this data. Then multiply by this uint 8. So this is our binary data. What is this 36? I calculated it at the time. 36 should be calculated like this. That is to say, there is a 4 byte here, and this struct is 24 bytes, and this struct is 8 bytes. So that adds up to 36 bytes. Therefore, this is a fixed 36. We can see here and in this place. So this is the binary data. Then this first header information, we have it ready. Next, let's write this. This format information, first we take this ChunkID and put it in. Create one of these. And here, be careful not to add the txt extension. Use native characters here. Then this is its check size, and its eduform, and its number of channels. Its sample rate, and its 16-bit. Okay, and here we calculate its bit stream. It should probably correspond like this. And here is its alignment method. Okay, good. If you want to parameterize this thing, you need to expose these parameters to this interface. Since we have already fixed it here, we won't worry about it. Then here we will bake this custom data into it. What is baked here is this lumber. This lumber, you can see, it is this. That is how large our custom data is. After doing this, then we will now put our data into the data we want to output. First, let's put this header information in. Right, let's put the header here. Put it here. Then, hey, it's pasted wrong here. Okay, next, let's also put the information of the remaining two styles here. Then when you add it, there will be an index here. Because you're not adding from the beginning. You need to start adding from a certain element. Right. Oh, let's stick it together. Okay, then after doing this, we put our binary data in with this method. We have converted this data into PCM data. Then let's go back to our this thing here. Let's take a look. Basically, this part is done. Now we can test the effect. I'll test it here. Okay, let's start the test here. Okay, it's already started. Let's go back to our observation chart. So here, this execution pin, the success pin, it should be triggered. Let's print this text for him. Then next, let's determine this object. It should be valid. Then we'll play sound. If you want to listen for the end of audio playback, you'll need to use A to C A P C H. Just use the component to play it. Here, now, let's try it. Try it. Okay, you should be able to hear the sound. That's how we play the segment. This is normal. Let me turn the volume up a bit. Okay, why does this thing... Right? Let me test it again for everyone. The microphone. Okay. The reason it's playing like this is because the engine has changed something. So we won't deal with it for now. We'll leave this issue for now. If it works normally in version 5.3, we won't demonstrate it. Next, let's handle how to save it as a WAV file.